To get exactly one real solution, the discriminant would have to equal 0. Since when we take the square roots of 0, we get 0, that means that if we were solving an equation with b filled in, then we would get, besides exactly one real solution, it would be a rational number as well, because there are no more square roots in it. Now, I'm going to leave b as a variable here and fill in a equals 16 and c is 4. Four times 16 is 64. 64 times 4 is 256. So what we're coming up with here is a new quadratic equation with b as the variable, and we could use the quadratic formula with b equals. We'd have to watch out for confusing the variable b with the coefficient of b. But it would simply be easier to add 256 to both sides and apply the square root property, which is going to cancel on the left. Take the square root of 256. Oh, don't forget the plus or minus. We actually get two possible values of b. As a quick version of a check, that would mean that we've got 16x squared plus 16x plus 4 equals 0, or 16x squared minus 16x plus 4 equals 0. Each of those you could try solving by the quadratic formula, or each of those is a perfect square trinomial. 4x plus 2, that quantity squared, or 4x minus 2, quantity squared, equals 0. And so for the first one, apply the square root property. Square root of 0 is 0, and it has no sign. We're getting exactly one rational solution. It's real, but more specifically, it is rational, integer over non-zero integer. Whereas for the, if you use b equals negative 16 in that second equation, you're going to come up with x equaling positive 1/2, because we just have a difference in the signs between the 2 and the negative 2. And that does it.